For the second part of the video problems in homework set number 8, we were asked a power station is on one side of a river that is 0.5 miles wide, and a factory is 6 miles downstream on the other side of the river. It costs $6 per foot to run overland power lines and $8 per foot to run underwater power lines. Determine the amount of overland and underwater power line estimated distance in feet that minimizes the cost. Now, I first want to draw a picture so we can understand what's going on here. We'll start off with the point A, which will be where the power plant is. Then we will go to the other side of the river, which is 0.5 miles. And then we know that down that river, 6 miles away, is the factory. We'll denote the point on the other side of the river, perpendicular of A to the river, is B, and where the factory is as C. Now, we want to know the cheapest way to get from A to C when we know that it costs $8 per foot to do underwater power lines and $6 per foot to do land power lines. We first want to begin by creating a function within this thing. So we want to start by denoting another point, arbitrary point of D that's in between B and C. We want to denote the distance between B and D as x. And since we know that this distance right here is 6 miles, we know that this little distance right here in between D and C is x minus 6. Now we want to write out a few things. We'll make this right here from A to D a distance of f. And we also need to know how many feet are in a mile, which is 5,280 feet per mile. Now that gives us 0.5 miles to feet equal to 2,640 feet. And 6 miles in feet equals 31,680 feet. Now, we want to make an equation for f, and then we want to add on x minus 6 to find the total distance. Now, this will just be the total distance, but we want to do $8 per foot for underwater and $6 per foot for overland power lines. Now we want to denote the cost as M, be the total cost in money or dollars, a currency if you will. And then we know that it is going to be $8 per foot times F, which is the distance from A to D. Then we want the distance from D to C. We'll denote that as some E distance. Plus $6 per foot times the distance E. Both F and E will be in feet. That's why I converted it up here. Now F is equal to the square root of x squared plus 2,640 feet squared. It's going to be a big number. And we know E is equal to, I actually got this wrong here. It's not x minus 6, it's 6 minus x. Glad I caught that. Okay, E is equal to 6 minus x. Miles. This is 6 miles. So we need to change that to 31,680 feet minus x. Now, I'm going to write this out as very large number, but I'm going to keep it as 2,640 just so I don't have to write as much. 600 feet squared. Now, what we want to do is plug all that into M. I'm going to I'm just going to act like there aren't any units. Okay. Now we have this equation. I'm going to simplify it a little bit by pulling out the 6 into that parentheses equation. And it's not plus, it's a minus. Okay. Now, we want to know the lowest cost to get from A to C. So we want to do a derivative of M with respect to X, the distance from B to D. Now this is the distance we aren't going to be using at all. We are going to be bypassing it because we want to make the distance from A to D plus D to C the lowest distance. And so we do a derivative of dm with respect to x, and we get 2x from inside the square root times 1/2 times 8 all over square root of 2640 squared plus x squared. Now, the derivative of 190,080 is 0, so we have just a minus 6, and the derivative is 6x. Now, we simplify that into 8x over the square root 2640 squared plus 8x squared minus 6. Okay, now to get a minimum or a maximum, we want to set this equal to 0. So dm over dx equals 0. That equals 8x over the square root Okay, so then we move the 6 over, we get 6 equals to 8x over the square root of all that. Now, I'm going to move the 2640 squared plus x squared square rooted over to this side, which means 6 times the square root of 2640 squared plus x squared equal 8x. Now I am going to square this whole equation. I'm going to move to the next piece of paper because I'm running out of room. Now, we have 6 times the square root of 2640 squared plus x squared equals 8x. Square all this, and you get 36 times 2640 squared plus x squared equal 64x squared. Now, multiply out the 36. I'm not going to do this big number because it's going to be useless to write it out. I will at the end, so that way we'll get an image of what's going on here. Okay, now I'm going to move the 36 over by minusing it over. We'll get that turns out to be 28x squared. So then we divide the 28 over. Now I'm going to do this whole, I'm going to write out what that all equals. And that is 8960914. Square root all this, and you get x equal to 2,900, 93.479 feet. Okay, now we know that that is x, but we want to find the distance that for the overland and underwater power lines. So we know that F is for the underwater, which is equal to square root 2640 squared I'm getting my notes flip-flopped. Okay, so we got 2640 squared plus x squared, which is equal to the square root of 6,969,600, which is 6,969,600 feet squared, plus 2,993.479 squared, you square root all that, you get 3,991.31 feet. About equal to that. There's a few more decimal places that I didn't put in. Then, from the point for the equation E, we get that 6 miles minus x, which is 31,680 feet, minus 2,993.479. Which turns out to be 28,686.521 feet. Now, we times them by their relative cost per foot underwater and overland power lines. So M equals $8 per feet times 3,991.31 feet plus $6 per foot times 28,686.521 feet, and we get M is equal to $204,049.57. I'll just put the dollar sign on the end, even though it's supposed to go in the front. Now, we know that we can plug in things that are similar to M and get the relative min or max, or we could do the second derivative test. I decided to just put in M of 2,994, which is equal to essentially the same thing, but this one has a lower decimal point, but they still equal the same thing. So 204,049.57, because you can't have less than 1/100th of a cent. And M of 2,995. Oh no, I mean 2 equals 204,049.57 as well. Okay. Now I also did some other calculations. 2,990 as a reference. Let me redo that. So way. Still equals the same thing out, which shows that it's a very slowly getting to a minimum But essentially, all these work out. And there's a range for it, but we weren't really asked to do that. But the smallest distance, the median distance for all these is exactly when x equals 2,993.479, which would be the exact minimum for the equation that I found, m equals $8 per foot times F plus $6 per foot times E. And we get that the total cost is this. The total distance for the underwater is 3,991.31 feet. And the total distance for E, or the overland power lines, is 28,686.521 feet. Thank you. Have a good day.